Had my mic
Hello,
muted. Oops, you're on mute. Right? It's like the. I need my shirt. I think they have those now, right? Like the you're on mute shirts. Michael, welcome. It's a pleasure to see you.
thank you. Good to see you, Ryan.
Yeah, likewise. Michael is the co-founder of pgMustard, which is a tool for bringing powerful insights to your Postgres explain plans, which I know personally, and honestly, the reason I first connected with Michael maybe close to 2 years ago, because it's really a confusing area for a lot of developers. He previously worked at Redgate, a company that I knew from my previous life in SQL Server. It's a UK company that develops tooling, and he worked as a product manager. And a connection we just made last week as we were talking, I didn't know this, that Michael has a long history in music as well. I know it's how he met his partner, and we were talking. My daughter was playing violin downstairs, and I said something, and I noticed a violin in the background, and that's really cool. What you get to know and learn about people as you connect. So, Michael, it's a pleasure. It's always been a pleasure to connect with you and see your heart for the community. So today we're going to talk about explain, analyze. And I love, you even said this could be a 3-hour talk in and of itself, right?
Yeah, right. I'm hoping to do the first 20 minutes and a kind of a beginner's guide, kind of a 0 to 60, give people some practical tips for getting started. But yeah, that's the aim.
That's awesome. Let's go for it. And I'm just going to sit in the passenger seat and see where you go.
Brilliant. Let me just share up. Let me know if this is not coming through. Should be able to see a beginner's guide to explain, analyze in front of you. Wonderful. Yeah. So thanks so much for the kind introduction, Ryan. I think he's covered pretty much all of this, so I might be able to skip ahead. But yeah, the last few years I've spent quite a lot of time looking into explain analyze specifically. So yeah, hoping to give you lot the kind of the condensed 20-minute version of the getting started guide. Awesome. So we are going to start with just some basics. So what is explain? What's the difference between explain and explain analyze? We're going to go through a simple process that I recommend using when reviewing these query plans. Then we're going to look at some tools that can help you with some of those steps, and I'm going to point you at some places to do the next, beyond the basics. A little bit more theory as well, where you can learn more.
Awesome.
Yeah, awesome. So we are going to cover those things. We're not going to cover how to find these slow queries in the first place. So chances are, if you're looking at a query plan, you've got a query that's slower than you're expecting it to be or than you want it to be. And we're not going to look at any kind of monitoring or how to get these query plans. What we are going to look at, we're also not going to cover the every little statistic in detail. So that's where a lot of these beginner guides start, but I don't think it's that useful when you're actually starting to look into them for the first time. So we're going to skip that.
Awesome. I can't wait to... that's exactly how I tried to, right? You explain the thing and you look at this huge thing of text and it's like, what do I do? So
yeah, right. Explain, as Ryan is very familiar with, if you put that in front of your query, you'll get back, you might get back a wall of text, but what that is a query plan. So it's Postgres's execution, or its plan for how it would get you that data or execute that query. Explain, analyze. Analyze is technically a parameter for explain. So the idea is that it will run the query in the background, and instead of returning the data or doing the operation, it will gather statistics on those for you, measure the timings, that kind of thing. So super helpful for performance stuff. So I was going to take people through an example. We're going to use this example quite a few times through this, so you'll get used to it. But yeah, super simple one. We're going to run explain on a select star from table T and ordering that by a column name. We're going to read these inside out, so kind of bottom to top. So we start at that first indentation where that little arrow is, looking at a sequential scan on table T, and then you get quite a lot of information, but the most interesting to start with is the estimated number of rows that are going to be returned by that sequential scan before it then is going to sort that data in order to satisfy the order by name condition, and again return all 200,000 rows. So that's its plan. There are its estimates. And then with explain analyze, I'll show you in a second, you'll be able to see the actual runtime data as well. So a lot more information. And again, starting bottom to top, which we'll go over in a moment. But execution time there, we get how long it takes to run. So 346 milliseconds, that is. Planning time. So these are actually quite a useful way of thinking about the difference between explain, analyze, and explain as well. So explain, analyze will run in roughly the amount of time for the execution time plus the planning time put together, whereas explain, you'd get that back much quicker in approximately the time it takes just to plan the query. If that makes sense.
Complete sense. I've never thought about that. That makes complete sense, of course.
Yeah, well, the explain doesn't report the planning time, interestingly. You can get it to with a different parameter, but yeah, it could do if it wanted to. Yeah, so importantly then, the extra information you're getting here, I've put the most pertinent stuff in bold. So working bottom to top, the sequential scan you can see has got now an actual time, and it's the second of these two statistics, the one after the two dots that's the total time that's most useful. So that's 60.296 milliseconds to return actually 200,100 rows. So a little bit more than the estimate that we saw a second ago. And then moving backwards, you can see that the sort operation also gets that additional actual time and actual rows data put in, as well as a bit more information about how Postgres did the sort. And in this case, it used an external merge algorithm, which took place on disk rather than in memory, and how much disk that used. So yeah, a lot more kind of performance data, and start to give you an idea of what exactly does happen when it runs it.
Yeah, for sure.
Awesome. So explain analyze is super useful. These are only going to come up every now and again, but I think it's worth covering a couple of quick caveats. It can underreport or overreport the amount of time in some circumstances. So if you are in one of those circumstances, I thought I'd explain why that could be. So with explain and analyze, you're only getting the time spent on the server, and you're not getting, for example, so if your query returns a lot of rows, it's not actually transmitting those rows to over the network to a client. So if you're seeing a much higher time in your client than you see in explain analyze, that might be the reason. Equally, if it is over-reporting the amount of time taken, so you're seeing a faster time in your application or your client than you're seeing in explain analyze, you might be suffering from the observer effect. By measuring timings, you're actually causing a little bit of additional overhead. But on modern systems with fast get time of day calls, it's very rarely an issue as far as I can see. I think maybe on like Docker, that kind of thing, but it's not something I've personally seen much of.
Yeah, that's interesting. Even based on David's talk just before this, and in our work in time series data, which is always generally a lot of data and a lot of rows, and you think about things like downsampling and some of those exact reasons why, knowing how to understand what's going on in the query so that what you really need to return, you don't necessarily even need to return 200,000 rows, right? Maybe that's not what actually needed to happen, and you didn't realize that's what was happening under the covers. So
yeah, exactly. But yeah, a lot of the time, actually doing operations on those 200,000 rows, you're going to still see performance problems. So quite a lot of the time, let's say you've got a missing index or a really slow sort, that's still going to show up, even if the timings aren't quite what match the real world timings. You might still be able to spot the main problem through explain analyze, even if the timings don't match up perfectly.
Yeah, for sure. Great point. Cool. All right. Well, let's look at what's your process?
Yeah. So, well, I'd love to hear your process as well, Ryan. But this is one that's mostly based on things not to do. But I've tried to make them really positive.
That's great.
So yeah, the first and most important, I think, is to run explain analyze on as realistic a data set as you can. I'll go into the details of that in a moment, but the second point is to get as much information as you can. So there are other explain parameters as well as analyze that I recommend making use of.
Perfect.
As we've briefly touched on already, start at the bottom and work your way up or inside out. Then this is the crucial bit that I think a lot of experts forget, even, and I sometimes am guilty of, is to work out what the most expensive parts of your query are first before trying to look for problems that you maybe have learned to look for. So yeah.
Oh yeah, I mean the number one there, I would just say from my many years of just application development and working with teams, it's like a universal law for some reason in development that developers are almost never using a database that is close to or mimics what's actually being served in the real world. And how many hundreds of times you're like, but it worked on my machine. Well, of course it did, because you had 100,000 rows and production has 100 billion, right? So there's got to be, that's a great point to better understand how the planner's working, statistics and so forth. So.
Yeah, exactly. And it can lead to days of wasted time if you don't.
Yeah, for sure. Cool.
Right. So, do rush me if I'm running out of time at all.
Doing great.
So number of rows is especially important. So yeah, I understand that it's not always possible to test on the actual data. Getting, especially with in terms of respecting people's privacy, getting real data is not necessarily the goal here, but the number of rows is especially important. And that's because, as we'll see in a moment, Postgres is using the estimates for those numbers of rows in order to choose which join algorithm or sort algorithm it uses. And it can even, I think this trips people up quite a lot. If you've got a tiny table on your development box, then it might do a sequential scan, even if there's a good index it could use, because it's just so easy to do and efficient to do it that way. Yeah. So yeah, it can even affect scan choices. So yeah, that was the first point. I think where I made a lot of that point for me, which was great. And then so the second part is to get loads of information. That the process I'm going to teach you here will help you skip a lot of it. I think sometimes people get put off by requesting all of this because it will give them a big amount of data back. But if we can skip to the most important parts, getting this information will help us diagnose the issue once we get there. So as well as explain, analyze, and this is kind of in order on how important I think they are, but yeah, buffers, a lot of people think should be on by default with analyze. I tend to agree with that, but it's not, so you have to request that separately. I think settings could be on by default as well. That's super helpful. So settings and verbose both help you, but they especially help anybody that isn't familiar with your system to help diagnose issues. So if it saves you getting the query plan again when you're seeking help. So yeah, they're particularly helpful. And then one thing that's not an explain parameter, but does put more useful information into it is set track IO timing on, which, as the name suggests, tells you how much time was spent doing IO.
Oh, wow. I don't think I've ever turned that on. Good call. I don't want to keep, this is how I work. I love just having the conversation, so I apologize. But could you just really briefly talk about buffers? This is honestly one of the things I suggest to every single person I ever show. Could you just quick summary of why that's important?
Yeah, so timing's really good for, so explain analyze will give you timing. There is a timing parameter and you can turn that off if you need to, but it's on by default. And that will tell you how much time is being spent in each operation. And when you're tuning queries, you're generally trying to focus on how do I make this as quick as possible. Yeah. But there is another element to it, which is kind of efficiency. So it's normally quickest to do it in the most efficient way, but Postgres does now have some tricks to do. So you can, for example, parallelize queries. Now that might do quite an inefficient scan, for example, but because it's able to use a bunch of workers, it comes back faster, so it might opt for that. But the buffers will tell you the amount of data being read and written, and that's another measure of efficiency that you don't get from timings alone. And I think that's hugely valuable. Without even mentioning that it can tell you, give you an idea of whether there's a caching problem, whether maybe you're cache limited, you're reading a lot of data that's not in Postgres's shared buffers, for example. or you're writing data to disk, which we will see in a second. It will give you temp data read and written as well.
That's great. Thank you. Yeah, those are awesome points. And you know, the analogy I always use, it's generally, not always, I mean, there's always an exception, right? But it's generally faster or more efficient to not do work, right? So if you can measure not reading pages to satisfy a query because half of them get thrown out in a filter, wow, you know, you've done something to improve the efficiency of what's going on there. So cool. Yeah. Keep going.
Absolutely. Cool. So third point is to start at the end. So we saw in that example that the planning time's there, and as is the execution time. The reason I recommend this is query plans, especially as you get more complex analytical queries, they can get quite long, quite lengthy, and you could spend a long time looking through it and then only realize right at the bottom that the problem was one of these three things. Either it could be planning time dominated, and there's a few reasons for that. Could have been spending a lot of time in triggers, which wouldn't show above. And the other thing that can catch people out is just-in-time compilation, which there are sometimes clues in the query plan for, but I recommend checking that total time at least, just to make sure that's not half of your execution time. Because if any of these are more than half of execution time, there's very little point looking into the rest of the query plan to work out what's going on.
Man, great points.
So yeah, quick, that can save hours. But yeah, cool. This is the meat of it though. Once you're familiar with those things, they'll become second nature. You'll have shortcuts for running explain, analyze with all of the parameters, and you'll be working on your dev box that's got loads of data on it. So this is the bit that's probably most useful on an ongoing basis, is to either find a tool you like or work out how to tell where the majority of the time's going, or what's doing the majority of the work in your query plan, or whether it's a lot of quite expensive things and this is actually quite a fast way of doing the work you're asking it to do, and maybe you need to rethink the solution. Okay. So yeah, the thing that catches people out though with this one, and this is where I think tools can be particularly helpful, is a lot of the stats include the timings of the operations below them in the plan, or to their children effectively, if you think about it in nesting. Not only are they inclusive children, but they're also a per loop average, so a mean. So look out for the number of loops, look out for the children times, and you'll be good, or have something else calculated for you.
That's great.
So we're going to look at that. This is the example, Ryan. So this is the same sequential scan and sort that we were looking at before, but buffers as well. But we're going to pick out here the actual times, and we can see that the sequential scan is reporting 60 milliseconds, and the sort is reporting a total time of 305 milliseconds. Now, if we subtract the 60, because it's inclusive of its children, that's about 246 milliseconds spent sorting alone, which is a lot more than on the sequential scan. So we can already tell that the sort is the majority of the time being spent here. And if this was potentially if this was a more complex query plan, it would be easier to focus in on that alone, and maybe discard whole other subtrees that are relatively fast.
Yeah, that's great.
Nice. So yeah, once you've calculated that, once you've worked out where the time's going, only then think about kind of the next steps on how to speed it up. And yes, I fall into this trap sometimes, but definitely a lot of people fall into the trap of looking for those issues first without doing this, without making sure you have checked where the time's going. So yeah, what I mean by only then work, what do you actually look at next? So it's all the other bits. The rows are a really good thing to check. Do the actual rows returned closely match the estimated rows? If there's a big mismatch there in a part of your query plan that's slow, that could be a really good thing to look into. We get the information. This is a sort, so we get what it was sorted by. Do we need to be sorting at all? That was a good point that Ryan made. Could we avoid this sort entirely? Could it be done in memory instead of on disk? How could we reduce the amount of data being returned, the amount of work being done? Do we need 200,000 rows, or are we just interested in the top 10 and we can fetch more? We can fetch more later if we need them, that kind of thing.
Yeah. Just really quickly, you know, and again, thinking about large data and time series, you know, with our focus, what happens if your estimated and your actual numbers of rows are vastly different? What does that generally mean?
Great question. Sometimes it's not a problem at all. So this is the kind of thing that can be a red herring. Sometimes Postgres doesn't have a choice as to how it's going to execute something. So if it's completely wrong, it doesn't matter because it only had one choice. But a lot of the time it does have a choice on how it would execute a query. It could join things in a different order, or it could use a different algorithm, as we mentioned briefly. So when it's making those choices, it could choose badly. So if it thinks there are only going to be 10 rows, it might choose to do a nested loop. But if in fact there are a million, a hash join would have been much more efficient.
Yeah, good point. That never happens.
No, exactly.
Very cool.
Awesome. So recapping on those, run on a realistic data set, get as much information as you can, start at the bottom, just in case that's where the most expensive stuff is, work inside out to see, if not, what is the most expensive part, and then, and only then, think about what you can do to speed it up.
Michael, just these 5, and I know we're going to talk about tools here for just a minute, but like, this is such a great quick recap. I can't wait to share this like short video with just everybody that asked, where do I start? This is such a great way to just begin thinking about plans and Postgres queries. So thank you for laying this out. Very cool.
Well, that's super kind of you. It was tough to get it into 20 minutes. Sorry if
I know you worked hard on it. So thank you. All right, so let's talk about tools a little bit, because obviously I get the plans. I know I need help. What do I do next?
Yeah, so there are way too many tools to mention here to help visualize these. A lot of IDEs have them inbuilt, but I'm going to mention and show you 3 here because they're quite different ways. These are one of them I work on, the bottom one there, so I'm definitely biased. But the top 2 we really like, and there's a couple of big strengths of those that people might be interested in as well. So I was going to show you all 3 and give you an idea of how you can use those to help with the process I mentioned. So yeah, this is the first one that I've said is I've coined as expert friendly. A lot of people mentioned, or a lot of times when beginners are asking for help from experts on the mailing list, or people need a hand with something, they'll share a link to this, which is super helpful. 2 things that it does really well: preserve the text format on the right, so people that are used to reading text format explain plans can still do so without it getting in the way. And then the second thing it does is it helps with trying to work out what's the most expensive part. So that's step, I think, was that step 4. So it does that by color coding. So it's doing the timings on the left. So that 245 on the left and the 60, they're the per node timings that we were calculating earlier. So it does that for you. It does the row estimations as well. So it's saying we're pretty much bang on, a little bit under, but not a big deal. And then it's showing you in red that there was an operation on disk that we saw, and how many megabytes of disk space that was using.
Okay.
So red bad, orange medium, yellow okay, or not so good.
Yeah, great.
The next one is 𝗙𝗶𝗀. So this is a lot more visual and is based on a really cool tool that was built by a guy called Alex Tatiant. So you might be familiar with Tatiant's PEV as an alternative, but this is they've officially called it PEV2, which is nice. This uses the exact same color coding, so orange being not so good and yellow a little bit less bad than that. So it's trying to give you an idea of where the biggest problem might be. You can imagine on a bigger query plan how this would look. But crucially, actually, this is the same query plan as we were looking at earlier. So these 2 accept text format and JSON format query plans.
Very good.
And one thing that I think people really like one of the things people really like in this tool is this visualization on the left. I've got it there done. I've selected time, so you can see the per node operation times. You can also select buffers, costs, all sorts in there as well.
Awesome.
So that's really useful for getting a quick idea of where's the time going. Okay. And this, a third way of visualizing these, this is the tool I work on, pgMustard. You can see on the right-hand side, we focus first on the timings. So that bar across the top will show you a breakdown of those per node times. So you can quickly see if there's one dominant operation or lots of medium-sized ones and which ones they are.
Very good.
And then we've tried to preserve that text format layout, so the indentation, as well as calculating the number of rows being returned at each stage, if that gets tricky. And then the one thing I think we're doing that's a bit different to everyone else is the trying to help you with that step 5 as well. So once you've worked out where the time's going, what can I do about it? So we try and give those tips on the left-hand side.
Yeah, very good. I think you're right. All these tools are good options. I found you because I was looking for a little bit more help and happened upon pgMustard, I think 2 years ago maybe. And so it's just great to see the community building tools to help where there is a need, right?
Yeah, absolutely. Yeah, exactly.
Right.
So yeah, it was funny that we connected pre-Timescale as well. It was pretty cool seeing your journey.
I know.
Awesome. So I'm very aware this was like a super basic guide and there's loads more we can cover. But in terms of where to learn more, the Postgres docs, as usual, have a pretty good section on this. It's quite theoretical and actually not as deep as you'd imagine, but still a really good starting point. And then there's a thought blog post that I recommend, specifically on Explain Analyze, and a really good roughly hour-long talk by Josh Burkus that he gave a few times. But if you get these slides, there's a link to it there as well. And yeah, that's the best intro that I've seen, at least in terms of the next steps. And then, yes, that last one is a glossary of terms that I put together last year, or at least I was the primary author on, and spent a lot of time documenting every operation, every field type you could come across in Explain, or nearly everyone. So that's you might see that pop up on Google search results every now and again if you're looking at what things mean.
It's awesome. I'll say when I run into community members who need help with Explain, I often send them to your website, particularly this Explain side, because I think you've done a great job documenting. From my background, SQL Server, we call them, I think, operators, and in Postgres, they're called nodes, right? Depending on who you're talking to. I remember I had a conversation early on, and so what do you mean by an operator? I'm like, well, the thing, the node, and just knowing how to talk about them. It is not the same from database to database. It really depends on how the planner was designed to interleave that data when you're doing queries and joining. And so it's so helpful to have a framework to talk about it. So I really appreciate that you've put that together and what you've done there. But
that's really kind. Thank you.
This is great. I love having like 5 quick points of how to like dive into the problem. That's what this is all about. That's just so much this is about. And your patience in helping people has just been really appreciated. So thank you. That's good stuff.
Awesome.
Anything else that you kind of think want to share about the community in general, or just what you see?
Well, yeah, I'm super conscious.
Anything that's exciting, with Explain Analyze?
Yeah, well, I guess it's not the most exciting topic for most people, but for me, it's I'm definitely somebody that gets frustrated when applications are slower than they need to be. But basically, don't be scared by that wall of text you get when you see it for the first time. I'm conscious this wasn't super time series specific. Kind of need to get into a little bit more detail before you get to those. But if you do check out the slides, there are a few bonus slides on the kind of top few issues that we see, one of which does come up quite a lot in time series stuff. So yeah, I'm also very happy, Ryan, if anybody has any questions, feel free to email me. I think that's my handle on the Timescale Slack, but that's still my handle on pretty much everything else. So yeah, please feel free to get in touch. It'd be great to hear from people.
And I will just throw this out as we end here. So Michael, as I said, it's just been a joy to get to know him over the last couple of years within the Postgres community. He and I have a very similar, every time we talk, he's patient with me. We have a very similar heart for the community and just how we can help the community move forward. We know that there's a lot of people that just need help with some of these basics. And so I love your heart for that. With pgMustard, I think you just had your first office hours last week, which I got pulled into. I couldn't attend. I was frustrated. I had it on my calendar, but so look at his website as well for help like that. And honestly, you'll see Michael in our Slack. I know I've seen you in the Postgres Slack. He's really a community member, and I appreciate that about you. So thank you.
Likewise, Ryan.
All right. It's been awesome. Thank you so much. This was a great 20-minute talk. I'm going to pass on more than once for sure. So thanks so much for having me. Yeah. And take care, everyone. Awesome.